Hi all, so welcome to another video of electrical machine design based on KTU syllabus. So today we are going to discuss the problems of our DC machines, the design problems from the DC machines parts. So the first problem is calculate the main dimensions of 20 kilowatt 1000 rpm DC motor given that BAV, that is our specific magnetic loading, is equal to 0.37 Tesla and AC, that is specific electric loading, is equal to 16,000 ampere conductors per meter. Make the necessary assumptions. So this is the question, and these are the given data in the question, and they already said that we can make necessary assumptions based on our requirement. Okay, so here we have to calculate D and L, main dimensions D and L. So we know that the way to find the main dimensions D and L is, first we have to find the value D square L from the output equation, that is the generator power. Okay, armature developer generator power in the armature PA is equal to C0 D square Ln. Okay, so from that we have to find the value of D square L, and we have to separate this D and L using any ratios. Okay, so that's the method, and we know that the separation of the main dimensions, that is L and D, okay, depends on the ratio of L by tau, mainly L by tau. But here in the question we don't have enough data to assume a value for L by tau. Okay, so normally we'll assume in that conditions we will assume it as a square pole phase machine. Square pole phase machine, we know that for a square pole phase machine it is the L by tau value. Okay, it is something between the 0.64 to 0.72, and the accurate value we are normally taking that L by tau as 0.7. Okay, and we know that the tau, that is pole pitch tau, is equal to pi d by p. Okay, so if you are substituting that pi d by p instead of this tau, we can find a relation between this L and D. Okay, so here L by tau is equal to L by pi d by p, but here we must know the value of number of poles, but it is not given in the question. So we have to find the number of poles first, then we can proceed. So for finding the number of poles, there are some steps for finding number of poles. That is, we know that the frequency of flux reversal should be lies between 25 and 50 Hz. So based on that only we have to take the number of poles, and also the current per brush arm should not be greater than 400, and the current per parallel path also should not be greater than 200 ampere. That also we know. Okay, and we have to choose a number of poles as to reduce the overall cost of the machine. Okay, so for finding the frequency first, we know that the equation is frequency f is equal to p into n by 2. That is our normal equation. That is, we know that the ns is equal to 120 f by p. Okay, so this small n becomes 2 f by p. From that we will get p is equal to pn by 2. Okay, so the speed in rps, n is equal to we know that rpm, that is rpm is given, 1000 rpm is given, so 1000 by 60 will get the speed in rps 16.67, and we have to check the values of frequency for different values of poles. That is, if p is equal to 2, then if you are substituting that p in the equation of f, we will get f as 16.67 Hz, and if p is equal to 4, we will get f as 33.34 Hz, and if p is equal to 6, we will get f as 50 Hz. So here this p is equal to 4 and p is equal to 6, the frequency is 33.34 and 50, that is in between this 25 and 50. Okay, so we can choose any of these two values, that is 4 or 6. Okay, and for finding the correct value, we must check for the current per brush arm. Okay, so we know that this is a 220 volt machine, so the power rating is given, it is a 20 kilowatt power, is 20 kilowatt. Okay, so we will get the current value as by using the equation P is equal to VI into 10 raised to minus 3. From that we can find the full load current I as 19.9 ampere. Okay, and the armature current IA approximately equal to I. Okay, I. So this is the total current 90.9 ampere. Okay, so since IA is only 90.9 ampere, for any choice of pole, the current per brush will be less than 400 ampere. That is, we know that current per brush, if it is a lap winding, okay, we know that the current per brush arm will be is equal to 2 into IA by P. Okay, current per brush arm. So here IA is already 90.9. Okay, 90.9. So whatever may be the choice of this P, always the value, okay, always this value, current per brush arm value will be less than this 400 ampere. Okay, so both the values, that is 33.34 and 50 hertz, okay, both are inaccurate values for this design, but in that conditions, okay, in that case we have to choose the highest number of poles. Here 4 and 6 are allowable, so here we have to choose number of poles as 6. Okay, if you are choosing a high value of number of poles, we can reduce the overall cost, so P is chosen as 6. Okay, and after that we can find L and D. Okay, so we know that this L by tau ratio is 0.7, that is we are taking it as a square pole phase machine, so L by tau is equal to 0.7, and we know that L is equal to tau is pi d by P. So if we are substituting that value of P as 6, we will get L is equal to 0.3665 D. This is the relation between L and D. After that we have to substitute it in the equation, and the power derived by the armature. So here it is a DC motor, and it is also a 20 kilowatt small machine, so we are taking it as a large machines. Okay, the motor is a large machine, 20 kilowatt machine, so we can choose the power derived by the armature P is equal to output power P, so P is equal to C0 D square L into N. So here C0 is equal to we have to first find the output coefficient C0. C0 is pi square BAV into 10 raised to minus 3. So BAV, the value of BAV know, P we know, AZ we know. Okay, and from that we will get D square L as P by pi square BAVS into 10 raised to minus 3. By substituting the values, we will get D square L as 0.0205 meter cube. So this is the D square L value, and after that we had to substitute the value of L. L is equal to 0.365 D in this equation. Instead of L, we have to substitute this value, so we will get D cube is equal to 0.0205 by 0.3665, and from that we can derive the value of D as 0.3824 meter and L as 0.1401 meter. That is, the value of D has to substitute in this equation. From that we will get the value of L, length of core, as 0.1401 meter. Okay, so this is the way of finding the main dimensions of DC machine given. So I hope all of you understand well. So thank you.